Hello. Okay. Okay, good. Thank you. Cool. So, hello everyone. My name is Ludo. I'm a staff engineer at Hiro, which is a company that I joined 3 years ago. So, yeah, just a bit of background before starting the presentation. During my first 2 years, I mostly dedicated my efforts on the Stacks blockchain. And after the launch of Stacks 2.0, I started focusing on developer tooling. And yeah, so this talk is about Clarity, a project that gently started on the side and that became a daily activity a year ago with a dedicated team. And so during this presentation, I will walk you through the different features that we have in Clarinet, and I will focus on two very recent features that worth being discussed a bit. So yeah, in terms of features being covered, we started Clarity with this simple idea. The goal was to enable blockchain engineers to be productive when they write smart contracts. When we launched Stacks 2.0, we had some tooling in place, but it was very cumbersome to interact with the blockchain and just check the validity of contracts. And so, yeah, so that was the very first feature, and it did require some work, special work. So we basically had to extract the Clarity VM, which is a component that we developed in the Stack blockchain for parsing smart contracts, analyzing smart contracts, and then executing them when developers send transaction and contract calls. And so we did this extraction in a very special and unique way. We make it so that component was able to be executable as a WASM module, and we'll see how it's going to be very important for the future. So we had this first feature, then we added something else, which was how can we test contracts efficiently? Like, what is the best way to write tests for smart contracts? And so for that, we came up with a pretty neat integration with Dino, which is some sort of Node 2.0 created by the creator of Node, actually. And so, yeah, this new runtime was written in Rust, which was very convenient for us. So we integrated that module as a library. And so with that, we have like a product that developers can use in a zero configuration fashion, meaning that they just have to install Clarinet and that's it. Like, they don't have to deal with dependencies and versions, and yeah, it's very, very straightforward. Then we've been working on optimizing the debuggability of contracts. So we approached that in a few different ways. So first, we augmented. So at some point, we created like a VS Code extension, and we augmented the features of that program to make it so we can step-by-step debug programs. And so we also have some sort of GDB experience in the command line. So that's something else that Clarinet offers. Then, yeah, at some point, we had all these developers writing and testing smart contracts, but yeah, they wanted to deploy contracts on chain. So we started working on that, and we will actually come back to this specific feature. And something else that we wanted to offer was the ability to see how contracts react in like a fully fledged environment with a Bitcoin node and a Stacks node and APIs Explorer. So with Clarinet, we have this ability to spin up private network on developers' machine. It's very powerful, and yeah, we'll come back to that. And so, yeah, with this feature set, we kind of put a stamp on the value proposition. And so as of today, Clarinet became like a 1.0 product. It's stable. It's been used by many developers. We received many feedbacks, and we also addressed all of those feedbacks. So yeah, that's very exciting. That's a very exciting news. And so yeah, in terms of what's next, I think that we want to improve collaboration. So how do we help developers interact with other people in the ecosystem? And we also want to handle Bitcoin as a first-class citizen. So that's something that we started doing with the latest features, but we might have to take some step backs and improve the connection to Bitcoin. So let's zoom maybe on the improved collaboration part. So there are two aspects that we would like to explore. So first, how can we help developers using Clarinet interacting with their teammates? And we also want to improve how teams interact with each other in the Stacks ecosystem. So let's talk about the latter. So we have this ecosystem. So smart contracts are pretty unique in the sense that they have this ability to communicate with each other, right? So as a company, as a protocol team, you design a protocol, like let's say, for instance, like an Oracle protocol, and then this Oracle protocol can be used for doing many things. And so, for instance, a team working on a swap protocol can use this Oracle as a pricing mechanism. And then let's say that we have a stable coins coming in. They want to be able to use that swap that will be using the Oracle. So we really want to be able to create an ecosystem where teams can work with each other. And that's something important that we want to address. I think that, yeah, we want to create some sort of primitive, some sort of consensus that would be helping teams to work together. So that's one of the reasons of introducing the deployment plans, which is something that was introduced a few months ago, I think. And so with deployment plans, the goal is to create some sort of standardized protocol for deploying smart contracts on any network. So these networks can be DevNet, ephemeral, private, testnet, public, or even subnets. As long as it's based on Stacks and Bitcoin, we would have the right primitives. And yeah, so we saw a few protocols launching, and we've been able to experience that deployments can be really complex. So today, I think that, before deployment plans, and I think even today, teams are still deploying their contracts using scripts and Stack.js because deployments are complex. So you need to handle dependencies correctly. You need to pay attention to the transaction chaining limit. You also want to initialize your contract before deploying some contract. You need to pay attention to cost. Like that's an interesting problem space. And so, yeah, the goal of deployment plans is to introduce some sort of domain-specific language. So today it's being implemented as like a YAML syntax. But yeah, like you have a set of primitives that you can use for like designing a plan that can be applied anywhere, like either in memory or on mainnet or on testnet or even on a subnet. And it's pretty like, yeah. So today we have these 4 primitives. So you can deploy contracts, call some contracts, send Bitcoin transactions, and then you can also use the wait for block control for like structuring the deployments. But yeah, so with these 4 bricks, you can already create a lot of things, and that's pretty interesting. And so why that's something that protocols should be using. So let's say I want to create a stable coin. I really don't want to create a swap, and I really don't want to create an oracle. Like if I can rely on some existing pieces, then that's great. And like today, if I want to pick one of these protocols being deployed, I would need to retrieve somehow the scripts that these teams have been using for deploying their contracts. And like most of the case, the scripts are not committed because they contain secrets and private keys for signing transaction and so on. So yeah, you basically end up with like a protocol that is really hard to redeploy and to compose on top of. So yeah, the goal is to really like, yeah, create a mechanism that can be open sourced. So yeah, you write this deployment script. It looks like a Terraform. If some of you are familiar with Terraform, it's very inspired from Terraform. And so you create those scripts for handling deployments. And these scripts can be committed on GitHub. They can be shared. They can be audited by third parties. And then they would be reusable by community members. Like yeah, to come back to my use case, like if I'm working on this swap, then I can pull these deployment plans for deploying an oracle, and then I can deploy that on my personal DevNet and do some end-to-end testing. Yeah, that would be very interesting. So I'll be demoing the deployment plans after this one. And so, yeah, so we talked about ecosystem. Now within teams, that's a feature that we also introduced somehow silently in Clarinet, but it's there. We need to like, yeah, work on the documentation, but yeah, so Chainhook is basically a PubSub mechanism to create event source architectures relying on Bitcoin and stacks. So it goes as follows. Chainhooks is a layer that can be run in a different manner. We will come back to that. And so this layer is observing a stacks node or a pool of stacks node and sorry, some Bitcoin. And then your app can basically register some predicates that will trigger some events coming from the Chainhooks layer to your application. We will demo this mechanism. And so, yes, so Chainhooks is available as it's completely open source. It can also be packaged in a different manner. But so when it comes to staging or production, you can either include chain hooks in your application if your application was by chance written in Rust. But if that's not the case, if you have like an app in, I don't know, Node.js or Ruby on Rails or whatever, like you can use HTTP-based communication to register new hooks and get some notifications from stacks and bitcoins. I think at some point maybe we will be working on some sort of cloud hosted solution, and if it's not coming from Hiro, that can be coming from anyone else. Like the whole thing is open source, so yeah, you can take the library and run with it. And one thing that we added recently is the ability to use chain hooks in Clarinet in a very, very nice fashion. And that's why we will be demoing. But yeah, so as I said, chain hooks are basically just like it's a two-part payload. So you have, you can define a predicate. So on the left, that's like a chain hook targeting Bitcoin transaction that will be sending a payload to localhost 3000 when Bitcoin transaction includes a P2P cache output equals to or blah blah blah. And so the chain hook on the right is so it's a stack chain hook that will be triggering events when CBTC tokens are being burnt by anyone calling the contract CBTC. And so, yeah, the new feature that I'm going to demo in a few minutes is solving like an interesting problem. So today, when you start working on a smart contract, like let's say we have a team working on a smart contract, you usually have different profiles. So you have like one blockchain engineer working on the smart contracts, and on and you sorry, that's a typo, but and then you have like a front-end engineer working on like integrating the UI, crafting a nice UX experience, and like usually you have some sort of tunnel at the beginning because like the blockchain engineer starts playing with Clarity, the contract, and yeah, like it can take a few weeks or a few months even to like have like a first version that a front-end engineer can look at and work with. And so with this new feature, the goal is to create like a better synergy between the contract engineer and the front-end engineers. So the front-end, so the contract engineer via the unit test create a specific test that will be emitting events that the front-end engineer can get to work on the front end. It could seems a bit abstract, but yeah, I'm going to demo that in a few minutes. But so with that, there is like a interesting incentive where the contract engineer needs to write tests for creating these states, and the front-end engineer will be reusing the states for designing the UI and testing the UI in all the states that the contract engineer created. So yeah, good synergy, and I think it's also a good incentive for encouraging best engineering practices because at the end you end up writing more tests. So yeah, let's look at this. So I have this project, Bitcoin Unleashed demo, where I have a simple contract. This contract is a CBTC token, so it's a basic implementation of the C10 trait. So we have a transfer method, and then we also have a mint and a burn method. So in this case, we are like demonstrating how like a centralized BTC protocol could be wrapping and wrapping tokens. So yeah, going back to the deployment plans. So yeah, in the context of this plan, I have two bricks. So the first one is retrieving an existing C10 token trait implementation from mainnet. And the second brick is taking the CBTC token and publishing the contract. So this deployment plan is a DevNet plan that we can test pretty easily. So for instance, if I Clarinet integrate, so Clarinet integrate is going to retrieve that plan. It's going to spin up a few nodes, like a Bitcoin node, a Stacks node, Stacks API and Explorers. And it will be executing the deployment plan. And so, yeah, should be able to see the C10 token trait being deployed along with the CBTC token. Let's wait for a few seconds. So yeah, in the main pool, we can see the C10 trait and the CBTC token, and then we can see in block 2. So this is block 1. In block 1, I can see the boot contracts. In block 2, I can see the contracts, the deployments coming from the deployment plan outlined here. So in this case, the Clarinet integrate picked the default DevNet plan, but you can have as many plans as you want. It's pretty flexible. And then, yeah, the funny thing is that you can also use deployment plan, not just for your initial deployment, but for deployment upgrades. Like for instance, if you want to replace a contract, or if you want to do some contract call, that's also something that you can do. Okay, so that's for the deployment plans. And so I wanted to talk about chain hooks. So I'm going to terminate the integrate stuff. Okay, so in this project, I have one unwrapped BTC chain hook that we're going to look at. So the predicate is the following. Every time a CBTC token is being burnt, I want to receive a notification on this endpoint. And so these kind of events are being emitted when the burn method of the CBTC token contract is being called. So yeah, that's something about clarity. When you call the FT burn method, there's an event authentifying that this event occurred that will be added to the transaction receipt And so, yeah, in this case, we are observing the specific events. Okay, so in this project, I also have a simple front end developed in Ruby on Rails. That's pretty straightforward. So, right, I'm going to start this server. And so here I can see like a basic admin page where, yeah, I will see some events happening there. And then I want to look at the test. So like we said before, as a smart contract engineer, my goal is to write a contract, but also to write tests and make sure that the things that we said the protocol is doing actually work. And so, yeah, in this case, I have like a simple test where I start by minting some CBTC token, then I burn some CBTC token. So calling mint once and calling burnt twice. And so now, if I just run the test, and if I pass the chain hooks that I want to evaluate, then I can see that something happened on the bottom. But yeah, so first thing, cool, the test passed, that's great. And then if I look at my UI, cool, I can see that something happened. So there may be something wrong in my test. Or maybe that was, yeah, okay. That's maybe so that. Like I have like a very interesting flow where, yeah, okay, there may be an issue on the parsing step, but yes. Yeah, so anyway, the goal was just to demonstrate that we can create a very nice synergy between like the contract engineer and the front-end engineer. Like you don't have to run a Stacks node or whatever. It's just you take the project, you run the test, and it builds a state that you can use for your front end. And yeah, it's pretty exciting to introduce this feature. So yeah, I think that would be it on my end. If you guys have some questions, I'm happy to take some questions. But yeah, thank you for the presentation. I'll take the questions. Chat. Can you zoom the screen? Yeah, that may be too late. Cool. Yeah, so thank you for your time and see you soon.